Unit 3, Part 4. So we've just finished demonstrating that P after Q is a non-truth functional sentential operator. So what that means, similarly with proving that Steve believes that P is non-truth functional, it means we cannot construct a truth table for P after Q, right? So just focused on the first row where P and Q are both true, right? We had two examples or two instances of that row. We had two instances in this row, right? The first was Obama was president after George Bush was president. The second was George Bush was president after Obama was president. Both those examples, two pairs of sentences, both of them had both true inputs, because it is true that Obama was president, it is true that George W. Bush was president, right? So true in both cases. They're both instances of the first line, right, where the truth values of the two inputs are both true. But in one instance of this line, P after Q of true led to P after Q being true. Obama was president after George W. Bush was president. But another instance of this same line, right, George Bush was president after Obama was president, led to P after Q being false, or led to the output being false, which indicates again two divergent arrows, right, which contrasts with this arrow here, right? This arrow here for P and Q, right? P and Q is truth functional. The truth value of P and Q is determined entirely by the truth value, by merely the truth value of the input sentences. But P after Q, the truth value of P after Q, what these divergent arrows show or express is that the truth value of P after Q is not determined entirely by merely the truth values of the input sentences. Right? The actual content of the sentences, or in this case the order of the sentences, also can affect the truth value. Right? So P after Q is not truth functional. Sometimes two true inputs lead to true, sometimes two true inputs lead to false. Okay? So that should give you a good handle on truth functionality. And that's what, as I say, truth functionality is what makes tables, truth tables for our 5 operators possible. Okay? It's what allows truth functionality, gives you, this is the functionality from input to output. And we have, and in the opening section of Unit 3, Klenk presents you with the truth tables of our 5 operators. And she has discussions of each of the operators justifying the particular truth table she has. I am not going to run through all the truth tables. You have to read through that, and you absolutely have to memorize it. Not only that, but you will have to do lots of exercises, and especially quizzes and exams, where you're applying those truth tables, applying the knowledge, right, that is expressed in those truth tables many times, over and over and over again. Okay, it's what goes into computing truth tables. What you'll be aiming for, as you can see from the practice quiz 1 that I would have sent you, what you'll be aiming for is being able to do the exercises, especially at the end of Units 5 and Unit 6. That'll be a lot of your first exam. Okay? A lot of your first exam will be using the full truth table to test argument forms for validity. Chapter 6, you're introduced into a few more truth table concepts, like tautology, contradiction, understood as certain features of truth tables for formulas. Tautology, contradiction, contingency, logical implication, logical equivalence. Those are the concepts discussed in Unit 6. You need to aim towards being able to answer them. And that is absolutely requires having memorized the truth tables, being able to apply them in complex situations. I'm not going to go through them. Let me recommend learn how to say in summary form the knowledge expressed in each truth table. For example, the truth table for the conjunction is as so, right? Learn to be able to say and express it like this and say, okay, the conjunction is only true when both conjuncts are true. right? It's the conjunction is true when both conjuncts are true and false in all other cases, right? Or the disjunction, the truth table for the disjunction, right? No, is P or Q. It's true, 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 false, right? You can read through the discussion in the book as to the justification, especially for this row, where both are true. She just stipulates that we're going to be using the inclusive or, right, where P or Q counts as true when they're both true. We're not going to have a symbol for the exclusive or. Sometimes in English, P or Q means one or the other. You could have coffee or tea. Coffee or tea is included with the price of the meal. That's her example, which means either one or the other, but not both, right? But we're just stipulating that this symbol means it's true when one of them's true, and it's true when both of them's true, and it's false otherwise. So learn to express it, learn to say, okay, P or Q, the wedge, is only false when both disjuncts are false. Disjuncts are the inputs for the wedge. It's only false when both disjuncts are false and true in all other cases, okay? The horseshoe, right, the symbol for the if-then, learn to say the horseshoe is only false when the antecedent is true and the consequent is false, right? And it's true in all other cases. That is the other three cases, right? P hook Q is true, false, false, false. The biconditional, P biconditional Q is true when both inputs have the same truth value and false otherwise. Learn to speak like that, right? It's true, false, false, true, right? True when P and Q are both true. True when P and Q are both false. But if one's true, if it's true, false, or false, true, it's false. It's true, false, false, true. Okay? Now, as for the justification, I'm not going to go through the justifications much. I will just say, make a remark about the conditional. The longest discussion is on the conditional, and you don't need to worry about this too much. You can get by in this course just by memorizing the truth tables for each of the formulas, right? For ones like and or, it's pretty intuitive, right? You know what and means, you know what or means. If then is not so intuitive, and there's a long discussion of it, and I just want to highlight, I think, to sort of state, conditionals are very, very philosophically tricky, and Klenk's discussion and attempted justification for treating the conditional, the English if-then, as the material conditional, as an operator which has this truth table. Sorry, I got it wrong. That's not it. True, false, true, true. This. Sorry. True, false, true, true. I get it wrong. This one. Klenk's justification for that truth table is probably inadequate. Right? She assumes that it's a truth functional operator. Right? I'm thinking especially of what she says on page 40 to 41, when she says, one possibility that might have occurred to you is we might simply leave the third and fourth rows blank for the horseshoe, but there's a very good reason we don't. We want to be able to determine the truth values of the compound sentence in all cases, and if we left blanks, many of our sentences would have unknown truth values. That's not much of a justification for treating, we're going to be translating the English if-then as the hook, right? It's begging the question, really. She's assuming that it's a truth functional operator. In saying we want to always be able to decide, right, to always give a determinate truth value as opposed to leaving it blank, right? So I just want to indicate that if you go on and do higher logic, you will probably come back and read her justification of this truth table for the hook as inadequate. So the counter examples she gives on page 40, right? The way we're stipulating the meaning of the horseshoe, where it's true it's true when it's false true and false false, right? False hook true is true, false hook false is true. So you get that all these come out true on the top of 40. I won't actually read them even, but all these examples it gives about atomic bombs dropping and atomic bomb drops and everybody lives. That's true. An atomic bomb dropped in New York in 2001 and everybody died. That's also true, right? If those are counterintuitive to you and you don't want to buy this, you don't have to. There are other philosophers working on different logics to avoid those counterintuitive conclusions. But you don't have to worry about it for this course. For this course, you can get by just saying, accepting the stipulation. Whenever you see if then in English, you translate it with a hook, and we're treating as true every case except when the antecedent is true and the consequent is false.